Hello everyone, this is Fahad Mirza and I welcome you to my channel. And now we have a video understanding model which is called as Apollo 3 billion T32. This model seems to have beaten even 7 billion parameter models in various benchmarks when it comes to video understanding. First, we are going to see what this model is, then we will install it locally, and then I will test it out with couple of videos to see how it does the video understanding. Apollo is a family of large multimodal models or LMMs, which has been designed to address a broad spectrum of video language tasks, including long form video comprehension, temporal reasoning, and multi turn video conversation. Apollo has already achieved state of the art performance across several benchmarks throughout. For example, Apollo 3 billion, which you see on your screen at the moment, has outperformed most existing 7 billion models with an impressive 55.1 on a long video benchmark, which is quite a feat in my humble opinion. So as I said, it supports long form video comprehension, even it can handle an hour long videos, which is quite impressive, I would say. Other than that, they have done a systematic exploration of the design space of video LMMs. That is where they have uncovered critical factors that drive performance. They have also released a benchmark which is called as Apollo Bench for efficient evaluation. So we are going to install it locally and then we will see how it works. I will drop the link to it in video's description. The good thing is that they also have shared a GitHub repo for Apollo where they have shared some of the code which you can readily use. So let's go and install it. Before that, let me give a huge shout out to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website. Plus, I'm also going to give you a discount coupon of 50% on a range of GPUs in the video's description. This is my Ubuntu system and I have one GPU card NVIDIA RTX A6000 with 48 GB of VRAM courtesy Massed Compute. First up, as usual, let's create a virtual environment to keep everything nice and separate. Now let's install our GCC compiler and CUDA. The reason why we are doing it is that we need to install flash attention and these are the prerequisites for it. And so now let's install flash attention with some of the prerequisite packages. It is going to take a minute, so let's wait. And now let's git clone the repo and cd into it. And that is done. Let's clear the screen. And now let's install all the prerequisites from this repo. And we will be doing it in the editable formats. This is going to take few minutes, so let's wait. All the prerequisites are done. Let's now launch our Jupyter notebook and then we will download our model and play around with it. Okay, so let's first download the model and its tokenizer. It's the usual code where we are importing some of the libraries, torch and transformer, and then we are downloading this Apollo 3 billion model. There is also 7 billion and I believe even lesser than that, but I think that 3 billion is quite good in terms of balance. And then we are putting it on our CUDA device, getting the tokenizer, and then just loading it with some of the hyperparameters. And the model is downloaded. Next up, let's do the inference. For that, I'm just going to use one of the video from my local system. So this is the one which I'm going to use. It's a very small video. Let me play it for you first. So this is a video which I generated with AI some time back just to use it in another model. So you see there is just a cat who is walking on some sort of hill or mound. So let's see what this model does with it. So I'm just going to stop it. Let's go back to our code. So if you look at this code, we have given it a video path, then a question, and then we are loading the video, and from there we are getting some Quen 2 models with it, and then because we'll be doing visual question answering, so that is the template which we are generating for it. Then we are using tokenizer to convert all of the prompts and stuff into tokens, and from there we are using some of the hyperparameters to ask the model to generate the output after comprehending the video and then we are using the tokenizer again to decode the output, and then we are printing it. So let me run it. And there you go, we have our response. So I will just put the video here and then I will read through it. Okay, so it's a bit big, so I'll just read it. A sleek cat stands atop a rolling hill, lifting one paw in mid-step at its surveys its surrounding. So let's see. I'll just play it from the start. There you go. So yep, it is, that is quite good, not bad. And then there is some mound, and then there are some mountains in the backdrop. Or if you go back here, it says that gentle hills stretched out behind, a soothing backdrop of blue and brown that complements a cat's agile form. I think it is perfectly spot on. Let me also show you the VRAM consumption. So it is at the moment around 6.4 so gig of VRAM, which is not bad for a model which is understanding the video. That is actually quite good. If you go through this paper, this is one of the best written paper I have seen in a while, and that is why it is number one paper these days, which means that since yesterday. And you can see that they have described it in very fine detail as how they have sampled the video, how they are agreeing on the optimal mixture of text, image and video data for this Apollo models training, plus how they have evaluated it, and they have also shared a lot of details around the training schedule, which is quite good, I would say. Next up, let's try out another video. In this video, what I'm doing, I have just given it this real world video which I just made with my phone. It's a ceiling fan. It's a close up, and let's see if it is able to recognize this, that it's a fan. Nothing much is happening. The fan is running, and that's all about it. So let me go back and run it. And there is also an audio with it, by the way, so I'm not sure if it can deal with audio or not, but anyway, let's see. Let's go back here and then let me run it. And there you go, it has given us the response, and the response is as usual quite good. It says a white ceiling fan spins rapidly, its sleek blades a blur as they slice through the air, which is quite interesting. Yep, see, so they are a blur in the air. Very nice, very fine. The fan's motor hums softly in the background, a gentle whir that fills the space. A light reflects off the fan's smooth surface, creating a subtle sheen that highlights its gentle motion. There definitely is a sheen, as you can see. There is a white light there. Amazing stuff. I think the model is of very good quality. It describes the video very nicely. I'm very impressed. So that's it. I hope that you enjoyed it. Let me know what do you think. I will drop the link to this model in video's description. I hope that you liked it. If you did, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thank you for watching.